Good morning, ladies and gentlemen. Today we are on page 93 of your student journal, and our objective or our goal is, today I will determine if the wholes are the same and if they can be compared. Okay, so today I will determine if the wholes are the same and if they can be compared. Okay, so let's look at our vocabulary first. Our first word says fraction, a numeric value that represents part of a whole or part of a group. And it can be represented as A over B with the slash or A over B with a horizontal line. This is usually the way that we see it in elementary school. Then the fraction is broke up into two parts. There's the numerator on top and the denominator on the bottom. The denominator tells you the total number of equal parts in the whole. So that is the bottom number. Okay, the whole is an entire complete object or set. So sometimes it's one object or sometimes it's a set of objects that we saw in one of our past videos. Equivalent means of equal value or equal to, and then this is a sign that means not equal. When we make an equal sign, I'll make it larger so you can see it with a slash through it. That means not equal to. Okay, so I'm just gonna get started so you can see what this looks like today. So here is my first problem, and it says, what fraction of each whole is shaded? Okay, well, remember the denominator tells me how many parts the whole has been cut into. So this whole was partitioned or divided into 3 parts. So that is my denominator. My numerator tells me how many parts I have. So this one means I only have one of the 3 parts shaded. So my fraction for this model is 1/3. Okay, let's look at this model. This has been partitioned into 1, 2, 3, 4, 5, 6 parts, which means my denominator is a 6. And my numerator is still a 1 because I only have one of the 6 shaded. Okay, so my next question says, can these fractions be compared? Yes. I can compare these fractions. The reason I can is we can say that the fractions can be compared because the wholes, and I'm going to run out of space, are the same shape and size. So because they're both the same shape, meaning rectangle, and they're both rectangles that are exactly the same size if I look at the outside of them, that means I can compare them. Okay, let's look at our next one. This one says, what fraction of each whole is shaded? Okay, so this one again is partitioned into 3 parts. So my denominator is 3, and I only have one of the 3 shaded. Okay, this whole is partitioned into 1, 2, 3, 4 parts, and I have 1, 2 of them shaded. So 2/4 is shaded. Okay, can these fractions be compared? No. So the reason is the fractions can't be compared because the shapes are different. And I should have maybe said the shapes of the wholes. I'm going to add that in there. So now it says the fractions can't be compared because the shapes of the wholes are different. So this whole shape is a rectangle and this whole shape is a circle. So I can't really compare those. Okay, let's look at page 94 together. Our first one says, what fraction of each whole is shaded? Okay, so this first circle is partitioned into 4 parts. So 4 is our denominator, and 1 is our numerator because only 1 is shaded. Okay, this part is partitioned into also 4 parts. And again, we only have 1 shaded, so 1's our numerator. So our fractions actually look the same, but these fractions cannot be compared. They can't be compared because the wholes are a different shape. So we can write the fractions can't be compared because the wholes are different shapes. So the fractions can't be compared because the wholes are different shapes. Okay, let's look at our next one. What fraction of each whole is shaded? Okay, well this whole was partitioned into 4 parts, and 1, 2, 3 of them are shaded. Okay, this whole was partitioned into 1, 2, 3, 4, 5, 6, 7, 8 parts, and 1, 2, 3 of them are shaded. Okay, so our fractions look different, but yes, we could compare these fractions. And the reason we can compare them is the fractions can be compared because the wholes are the same shape and size, because they're both circles and they're both the same size circle. So we can compare those. Okay, so ladies and gentlemen, you have the next couple pages to try on your own. Have a great afternoon.